Karthik, why don't we jump right in? It seems like a really a great space to be in where you're applying AI to really a lab space. So tell me, what was the situation before? How is this work being done? And then how does robotics automation start to be applied in this area?
Yeah, the conventional way of doing all this work, which I used to do for a long time, was all manual, right? You'd have a group of scientists that are in the lab. They first say, okay, I need to work on this formulation. I have a gut feeling of roughly what will work. And so we'll make a small set of experiments. We'll physically mix together our formulation. We'll physically then characterize it on the like classical equipment that exists out there. And then all the data, you get it manually. Then you make a spreadsheet out of it, right? Then you make a report out of it. And none of this is templated. None of this is automated. It's all fully manual. That's the classical method of doing all this work. Now, more and more, of course, the larger pharma companies are investing in automation. But I think automation in formulation is limited. It's much more applied towards the drug discovery side. So a lot of the plate-based cell culture kind of work. Once you get into making particles, as an example, not automated, right? It's a manual piece of equipment that you have to run. So that's what we've been changing on our end. We've been taking these, either taking classical equipment and then putting it together, like integrating it, modifying it, making a lot of custom parts. Or in some cases, we just say, you know what, forget the classical equipment. We're just going to do it on our own. And we're going to make a new piece of equipment that does the same thing as the original. Maybe it gathers the same kind of information. And then it does it in higher throughput and it's robotically actuated, right? Rather than a human doing all this work.